Back to the channel, and today we are going to cover quickshot algorithm. So quickshot is a divide and conquer algorithm. So it picks an element as a pivot and partition in the given array to around the picked pivot. So we are giving an array and its starting and ending position, uh, and it's saying we have to implement the partition and quickshot functions and to short the array. So what quickshot algorithm we will do is we will find a pivot element. Pivot is anyone or element in the array. It's not fixed that first element is pivot or second element pivot or last element pivot. We can pick anyone element of the array, and then what we will say at we have to play around the pivot. So let's see how this algorithm works. So array, say unsorted array, and what we will do is we first pick a pivot. We can pick anyone. Here we pick 6, and then move the pivot to the end, and then this array. So this you can solve, or another approach is you can pick a pivot. Like I am picking the fourth element. Then I am picking the first element as pivot, so I am picking 4 as pivot. Now what I am saying is if what is the correct position of 4? If the array is sorted like this, if this is the sorted array, this is the sorted array. If array is sorted, then where 4 will go? 4 will go at this position. 4 will go at this position. So what we will do is, what we can say this, if we fix the 4 at its correct position, then we can say that in the left of the 4 there is element which is lesser than 4, and in the right of the 4 there is element that is greater than 4. So but this we will do in this algorithm. We will pick a pivot and move to its correct position, and then we can say that in the left of the pivot there is element which is lesser than this, and in the right of the pivot element greater than this. So we again we use quicksort in this, and in this, and we repeat this until we can't find the until the array becomes sorted. So what we will do is we first pick a pivot. So pivot equal to the partition array will give us pivot. So TION partition. Now when we find pivot, then we can say that in the left of the pivot and in the right of the pivot, because the pivot at its correct position, so we don't need to short this pivot. We have to short the left of the pivot. So I am again calling quickshot the left. So array, and we have find pivot. So low and pivot -1. This is left part. This is left part to the pivot, and again calling quickshot. This is right part of the array, and we have to do this until when low and high are lesser. If low is equal to high, then we have to stop. Why? Let's see. This is pivot, and low is here, high is here. Then we can say that we have to call this, and we have to call this. Then low and high is same. Then there is one element, and one element is also sorted. You don't need to sort a single element. That's why if low and high is equal, then it's the function quits. So we can say that when low less than high, then we have to run the algorithm. When low become high, then this will discontinue the algorithm. So now we have to find the pivot, and when we have to move the pivot at this correct position. So our task is to move, to first find the pivot to find earlier. Our task to move the pivot to its correct position. We have to move the pivot to its correct position. So I am first selecting pivot. So pivot is ARR of low. I am saying first element is the pivot, then I am moving the pivot to its correct position. So for that what I am doing is I am using this concept that the left of the pivot is element is smaller and right of the pivot is element is greater. So if we find pivot, then we can say that we can start two pointers, one from here and one from here, and what we can say that we have to move this pointer until we didn't find a greater element. If the element is smaller, then we don't need to take care of this, because the smaller elements are of course the left part of the pivot. So we can say that if element is greater, then we have to swap with the elements which are smaller in this case. So smaller elements comes here, greater elements comes here, and array is sorted. So I'm starting from low and ending is high. So I'm starting from the starting part of the array, and second pointer is the ending part of the array. And what I'm saying is, while ARRS, uh, if ARRS is lesser than equal to pivot. So if elements are smaller than pivot, then what can say that we have to move pointer. We don't need to change it. Uh, Otherwise, if ARRE is greater than pivot, then you don't need to do anything. If there are greater element, then you don't need to do anything, and include the condition where s less than high, because if it's move, then it's goes till high, and also here include condition e greater than low, because you don't need segmentation fault. So when we do this thing, then we can say what we can do is, now we find the we find the greater element. So this less in this example, when say that this is pivot, and we can say that is there any element which is lesser than equal to pivot. So yeah, this is the element, and any element which is greater than, then we have to move any smaller element, fine. Yeah, 3 is fine. Any greater element, fine. Yeah, 4 is fine. So we have to swap 3 and 4, because 4 at is calculation and 3 moves here, because 3 is smaller than 4, so 3 moves here. Now there is case we have to swap it. We have to swap ARRS and ARRE. We have to swap it. But there is problem in the swap, because when we not need to swap when S and E are cross each other, or we can say that S is greater than E. Why? Because if S is greater than E, then we can say that here is pivot, then S moves here, and E moves here. So we can say that if S and E are cross each other, then we can say that array is already already the fix that pivot left elements are smaller and greater elements are greater than. Why you need to swap? You don't need to swap. So that if S is less than E, then only you perform swap, otherwise you not perform swap. And when we have to run this loop while S less than E, then you have to run this. If S greater than E, and don't need to run this. So while S less than E, then you have to find greater element from the left part and smaller element from the right part. Move until you don't find a smaller element, move until you don't find a greater element, then swap it. If both indexes are not crossed, then swap is, yeah. Now what happened? So S moves. So S moves here, E moves here. So now we have to put pivot at its correct position. So we have to move to swap ARR, pivot at its ARR low, pivot at ARR low. So we don't need ARR low as pivot, because pivot is value or ARR low is pointer. We have to swap pointers, not values. So we are using ARR low, and we have to swap with ARR E, or you can use ARR S minus 1 also, because E and S are equal, then this condition terminates. So S and equal, this condition terminate, or S E is greater than S, then this is also this condition terminate. So what you can say that you have to swap with E and ARR low, and we have to return the address the pivot. So return the index of pivot. So we have to return E. This is the index of the pivot. You are Let's run this. Let's run this. Then I will tell you some points. So yeah, correct. Submit this. So all test cases pass. Also, one thing you might confuse, like why I'm using ARR, not ARRS, or why I'm returning E. I will be show that it's always E, not S. So when you try the code, you can see that there is always the pointer, there is always the E, which adds the correct pivot position. Or you can say that if S equal to E, then you can use swap ARR low, comma ARR S or E, because S and E both are equal, else you can say that swap ARR low. Yeah. So when you try run this, you find that ARR E or S minus 1 both are at same position. E and S minus same position, but if S and E are equal, then it's S or E. But if they are not equal, then you can say that E or S minus 1 are same. So you can use either of this. You can use either of this. This is correct. You can either of this. This is both are correct, and you have to return E or return S minus 1. Here you can say that less than this, if it's correct or not. So yes, correct. After this is working fine. I will run this, where it out. This will also run fine. Yeah. So you can use either of this, and so yeah, this is the code, and this is the quicksort algorithm. Do subscribe if you find that this video is helpful. Thank you for watching.